So the next topic we're looking at is called graph coloring. And if you look at the map, one of the map problems that we saw earlier in this section, you'll see something common in a lot of maps, and that is the individual states or counties or countries or whatever they are will be different colors to make them easier to distinguish, to sort of tell where the boundary lines are. But actually it turns out an interesting question is, how many different colors are necessary to make sure that no two neighboring regions have the same color? So that's what graph coloring is called. That's a topic called graph coloring. And that was actually developed to answer that specific question for people who are making maps. And it actually had other kind of cool applications. So we'll talk about some of those. So just some basic terminology we're going to use when you say coloring for a graph. That's the method of coloring all the vertices so that any pair of vertices joined by an edge have different colors. So it's just important that's kind of the ground rules. The smallest number of colors that you need to make this happen is called its chromatic color. So the chromatic color, or chromatic number rather, for a graph is that smallest number of colors that you need. So what we're going to do, we're going to jump right into doing that. So we're going to color a graph here, and if you click on the explanation for Alex, it kind of gives you a possible strategy. The trouble is there's way more than one way to do these, and so it's not a foolproof strategy. So I'm going to use these different colors here just to kind of color the circles to kind of work this out. One smart strategy is start with the vertex that has a large number of edges on it. So I'm going to start with E, and the point is to use the smallest number of colors possible. And so if I start with E and I color that one red, so I'm going to color E red. And then the key is that A, B, and C can't be red. So I'm going to kind of think about these colors in order, right? So I'm going to start with, I'm just going to imagine red is first, then I'm going to use green, then I'm going to use blue, then if needed, I'll use this orangey yellow, and we'll see what the chromatic number is. And so you start with red, and so now I'm going to make this one. This next one is going to be green, and then I go back and say, well, this B can't be red because that would be connected to that. But it actually could be green. So I started with red, I went to red and green, and then I go, okay, start to the next vertex and start back over through my order of colors and say it can't be red, but it can be green. And notice that doesn't create a problem because C and B aren't connected. If C and B were connected right here, then I'd have to pick a third color. But what's important to know is that because they weren't connected, I don't want to use a new color unless I absolutely have to. So now I'm going to keep going, and I'm going to go back over here to A and say, well, A is connected to this, so it can't be red, but it can be green because get back to that, because that's my next color down my list, and A isn't connected to anything else, so that doesn't create any violations. So far I've only needed two colors. But then I go here and I say, well, I go back to this one, D. Notice D isn't connected to E. So the biggest mistake people will make is they'll think, okay, D's got to be a new color, surely. But no, D turns out, you go back to your list in order, D is just red again. So the smallest number of colors I actually needed to not have any two vertices connected by an edge that are the same color. So no two vertices are the same color connected by an edge. The smallest number I needed actually was 2. So there's my graph that's been colored. And what's the smallest number I needed? The chromatic number for this particular graph is 2. And just to show you just an example real quick of where this gets more complicated, or what makes it more complicated. If I go back to recreate this exact graph, E, C, E, A, and D, and so E goes like this, and like this, and like this, and then B jumps up here. Now, if we also did this, just one more little thing here. Well, so if we start back with that, and then go to that, notice B can't be red and it can't be green. So now I've got to go to a third color. So it's got to be blue. And then I go back to the beginning, and with every color you just consider them in order. It can't be red and it could be green. So I go back through my list. So looking at A, I say, can it be red? No. Can it be green? Yep. So then I go back to green. And then D again, I would go back to, can it be red? Yep. So now, that one then, that would be a 3 instead of a 2. Because I needed 3 colors to get that graph colored instead of 2. So just hopefully that helps you see kind of how you approach those. And that's all we're doing there.